Good evening and a warm welcome to you on behalf of Bangalore Sahodaya School Complex Association and ThinkTac. Wishing all of you a very happy new year and pray for God's choicest blessings on each one of you and your family members. We are immensely happy to have you all on board for today's workshop on NEP implementation, pedagogy, and tools. We have our evening speakers who will be taking you through the session. And I'm honored to introduce Dr. Procheta Malik, graduated with Physics Honors, BSc, University of New Hampshire, USA, 2005, and completed his PhD in Astronomy, University of Glasgow, UK in 2009, followed by a year of postdoctoral research. Upon returning to India, Dr. Prachet pursued his passion in science education by popularizing activities for schools before joining Innovation and Science Promotion Foundation at its inception in 2014. He co-founded ThinkTac in 2017. Welcome to you, Dr. Prachet.
Thank you.
Delighted to introduce Mr. Vishal Bhatt, graduated with engineering in computer science and completed his master's from IIT Delhi. Mr. Vishal worked with IT sector for 11 years, where he experienced programming as well as people management. His passion to be associated with education sector made him join the education domain, where he has been working since January 2011. After 2 years, he was a part of Nonprofit Innovation and Science Promotion Foundation and then co-founded ThinkTac in 2017. Welcome to you, Mr. Vishal. Immensely happy to introduce Dr. Jayanth Murthy, Senior Professor, Indian Institute of Astrophysics, Bangalore. Pursued his PhD from Johns Hopkins University, USA, worked at the Goddard Space Flight Center, NASA, USA, specialist in space astronomy with broad interests. Dr. Jayanth has published 272 papers so far in collaborating with the peers across prestigious institutions in the USA and India. He is one of those prominent scientists of the country who is popularizing science amongst the common folks, including children, for its deep and better understanding. Warm welcome to you, Dr. Jain. Ladies and gentlemen, we have three eminent personalities who are working towards making the education system enjoyable and effective, both for children and teachers. Stay tuned for this session. Over to you, Mr. Vishal.
Thank you, ma'am. Am I clearly audible?
Yes, you are.
Okay. Good evening, everyone. It's such a pleasure to see a large gathering of so many school leaders and educators. Before I invite Dr. Jayanth, I would like to set the context for today's workshop. May I request you to share your screen and put the presentation? My childhood days, I still remember this time of around 5 o'clock in the evening used to be a very crucial time, because every third day we used to receive water at home, and the entire family would be on our toes, and my mother used to really do. If a spoon was stable enough, she would also store water in that. Those days, if someone had told me there will be a time when drinking water will be nicely packaged in waterproof containers and it would reach to deep interior areas of all countries, I would have laughed about it, and more so if somebody told that people would also pay for it. Now imagine 10 years from now, I say that we will be paying in a similar way to buy 1 liter of fresh air. Of course, it's not something which amuses us enough, because it implies that if there is fresh air in the bottle, outside may not be as fresh. The times are changing, and changing really, really fast, and in many significant. Not all changes are as bad as they may appear. For instance, the 1 liter of fresh air app may have been developed by an Indian, most likely, to place the odd step quota to trying to paint a very gloomy kind of picture. My point is for the extraordinary times which the next generation is going to face, we also need to equip them with extraordinary skills. And that's what, in some sense, we all are here for. It's a collective responsibility of the schools, the teachers, parents, social enterprises like ThinkTac, and of course the government. And government has done its bit by launching the National Education Policy last year. So maybe you can move the slide, next slide, the presentation to the next slide. So there are many very interesting clauses in the NEP. We'll have a quick review of those. We'll have talk by Dr. Jayanth, and we'll also look at some of the pedagogies and implementation aspect. And here I would like to clarify that given that you all come with a vast experience, you'll be already familiar with them. Our focus is mainly on implementation. Just move to the next slide. There are many clauses in NEP which are well thought through and very, very fundamental in many cases. And we have selected a subset of those clauses mainly because it may otherwise seem overwhelming, though it all sounds very interesting. It may look overwhelming to actually put it into practice. And hence it's a small in today's workshop. Next slide, Pro. And the subset that we have selected is mainly a combination of these two aspects. One is the focus on the kind of competencies which the individuals in the 21st century would require, which is also collectively called as the 21st century skills, and this aspect about assessment. So how do you use assessment as a means to do that? Our proposal is, next slide, Pro. Our proposal is a combination of, yeah, we can also skip this slide. So this is a, we have picked a slide from this presentation from Education Secretary, which some of you may have also attended because it was also hosted by Bangalore Sahodaya, which specifically focuses on how to, what are the pedagogies for implementing the 21st century skills. So what we have selected is a subset where the engine which leads this three-bogie train is the reduced curriculum, so that we can focus on the competencies. Click next, Pro. And so as to develop those competencies, assessment and experiential learning, it's a combo of these two which we are proposing. Before making any further delay, let me invite Dr. Jayanth to share his perspective on experiential learning. Dr. Jayanth is one of our dear friends. He has always been with us with the Raman Awards finals as well. That's one of the national level competitions which we run every year, and he has helped us with the evaluations of the finals. Dr. Jayanth, over to you.
Okay, thank you, Vishal. So let me, Pracheta asked me to give a little talk on my, on experiential learning and the NEP. So let me give you my caveats first, which I also told him, which is that I haven't actually read the NEP. I've read a bunch of descriptions of it, but I did tell him that I did believe in experiential learning, so that I can do. So the caveats first. As I said, I haven't read the NEP. And in fact, the problem is that, you know, the new education policy replaced the old education policy, which probably replaced the even older education policy all the way back to British times. And everyone means the best. Everyone always wants to educate people in the best way. And so, you know, I'm not a great believer in education policies. These policies have to work with the teachers. And so it has to come bottom up, not top down by a bunch of civil servants or people like me who really are not educators. So with that said, let me tell you what I think about experiential learning, and I'll put it in terms of my own background, which is when I was doing my PhD, or even when I was doing my undergraduate degree, and I'm sure Pracheta has the same experience. In the US, what you typically have is you have a lab where you have experiments that date back to 1870 or something. And so you drop steel balls and you measure the value of E over M and all this stuff with equipment that may not be very good. And so you don't really learn a lot about the physics of what's happening from doing the experiments. What you learn about is how to do the experiments, what you do when things don't work. Otherwise, we read about all of this in the lab. I mean, in our textbooks. We don't know we don't know what happens when things are a little bit different. And this is a problem that I face with my students. My students are very used to reading all the equations. They're used to reading techniques. They know all of this. What they don't know is that the universe is messy. When we look at astronomical data, when you look at vaccine data, things happen. The data are not, it's not a perfect world. Let's say we're looking at the vaccine. Someone might get sick. Would that person have got sick even if you hadn't given the vaccine? Would they have got sick? Did they get sick because of the vaccine? And if you're just looking at textbooks and trying to understand these whatever is happening, you get completely confused. The only way to develop an understanding of how the world works is to actually sit and try to do the data, try to do the experiment. You do the experiment in the lab, and as Vishal said, I've been involved with this program for I think 4 years now. And every year I go to Raman's old house. Raman was, by the way, the supreme experimentalist. He took a prism and looked at the ocean and made great discoveries just by doing that, just by taking a prism and looking at the ocean. And so so in Raman's house, these kids, they come up with such great experiments. They've really thought about them. The better ones even think up variations. How do we show this using different ways? And this is what we really do need to encourage. And this is what I think the new education policy is trying to drive at. So as I said, in the labs that I had, these were labs that were almost an afterthought. The equipment was old, the techniques were old, but yet we learned what to do. We learned what to do when a resistor failed. Okay, we have to go change the resistor. When our experiment didn't work, as it never did the first time, we had to figure out how to fix it. and we always fixed it. When our results didn't look the way they should, we didn't fake our results. We went through and tried to understand why they were wrong. And the only way that you learn how to do all of this is by this experiential stuff, where you actually sit down, you build an experiment, and you see what's happening. These days, there are now so many more opportunities to get involved in this sort of stuff. For instance, the maker labs. These are great ways I'd gone to some school exhibition once where one of the students had put a mobile phone on a car, on a model car, and was using the phone to control the car. Go this way, go that way. And these are things where what it teaches you is new ways of looking at how to solve problems. When you're just doing equations, when you're doing problems, it's always the same thing. You're regurgitating matter. Your teacher tells you how to do something, and then you repeat that in the problem. And many times the problems are graded in such a way that the only way to do it is the way the teacher told you. But that's not true when you're actually trying to get things working. Whether you're trying to get computer programs to work, whether you're trying to build models, whether you're trying to use data. I mean, in astronomy, much of what we do is data driven. We don't actually build the experiment, rather we collect data using a telescope and then try to understand that data. But these are all aspects of this experiential learning, of learning where you sit down and you try to understand the world as it really is, and not as the equations tell you the world is. And so this is what I wanted to. This is the message that I want to convey. Again, as I told Pracheta, mine is always a free flow stream of thoughts. I never write anything down. And so this is what I want to convey, that what is important is figuring out what to do when things don't work right. And the only way to do that is with experiments. Many different kinds of experiments, but the only way to do that is with experiments. You use a paper straw, the paper straw dissolves in water. Oh my God, what do you do next? That's the kind of stuff that experiential learning does for you. And I do hope that this is something that is implemented in schools everywhere. I do think that it can make a real difference in our education system. So thank you for listening. I hope that was what you wanted, Pracheta. That's all.
Thank you, Jayanth. That's great. That's great. If anyone has questions, they can write them in the chat window. It'll be very hard to unmute everyone. So if you have questions, you can write them in the chat window. And Jayanth is here for another 10 minutes with us, and
Sure.
we'll be happy to answer any of those.
I see that a couple of participants have raised hand, and I'm not sure what they're looking for. In case you want us to unmute you, maybe you can put that message on the chat window, because we are close to 500 of us in the group. It would be unmanageable otherwise.
Vani ma'am, you've had your hand up. Did you want to ask a question? Yeah, so those who want to ask, we can always unmute them also.
I think what I said is so obvious that no one disagrees.
So that's fine. There's nothing on the chat window as well so far. Okay, there are a few questions now coming in. Okay. Let me try and get some of them.
Start at the top.
Yeah. So, is there a scope for experimenting till students get results in the curriculum and the time frame given by the Indian boards?
I can't really answer that question, but well, I'm not involved with school education per se. I do know, of course, I mean, you all as teachers know that there are already experiments in the curriculum,
That's right.
and how much more needs to be done. I think other people are better
Yeah,
placed.
and I think we can talk a little bit about that, about how an experiential, and that's part of our implementation
Great.
topic, about how much time is probably needed and some options. So that's a good question we can take up later in a more general sense. There's a lady here who's asked, what are your ideas for the subject of SST? I guess that means social studies, where we talk about history, experimental learning. So I guess for non-science
Yeah. No,
topics.
that's of crucial importance. When history is misread and misrepresented every day, I do think it is important. And I didn't mean to say only sciences, because academics is everything, and we do need ways to learn about uh, learning about history. I did when I did my history exam, it was actually fairly well done in that we were forced to write about our own interpretation of what we had learned. And I don't know. I mean, there are obvious things one could do, as things like uh, if you treat history as an experimental science, things like carbon dating, but that's too limiting. I think really what we should teach is the way that we go from incomplete facts to some sort of story about the past. I think that's a much more interesting thing, I I think it has to be done in schools.
Yeah. And I guess someone else has taken on from that. Is it confined to science alone? We also want to give experiential learning to maths. And of course, mathematics plays
Mathematics
well
is the
for,
language of science.
yeah, yeah.
We
And
and so
filled
this is
with
where,
activities and games and toys that you can do
yeah,
with
no, I
maths.
don't think I mean, a simple thing that you can do in math is finding prime numbers.
Mhm.
You use Eratosthenes, if I'm saying it right, the sieve, where you just go through and pick out prime numbers. I mean, there's a lot of fascinating stuff that you can do. And again, I find that some of the really interesting stuff is with random numbers. The way you can derive the value of pi from dropping pins on a piece of paper. You draw a square and you draw a circle, and you drop pins on the paper, and you take the ratio of the number of pins that fall in the circle over the total number of pins, and that'll give you the value of pi.
Right.
So simple stuff.
Yeah. We have another question. So when you're dealing with 1,800 kids, which each one is unique, how to go about this with experiential learning, how to provide positive learning?
Yeah, no, this is always the challenge, isn't it, when you're dealing with numbers? And I know that computers can really help. I know Khan Academy, for instance, that is a way to reach large numbers of people. So I I mean, Pracheta, maybe you're better placed to answer that than I am.
Okay.
You've got 500 people here.
Yeah, so there are a lot of questions that are coming for, I guess, the non-sciences. What do you do with languages? In social sciences, we take up studies to address a concept, what would be considered experiential learning, and so on. And I think in science, we tend to talk about a particular methodology, whether it's experiments, models, toys, that kind of stuff. When it comes to other subjects, it could be lots of other, it could be something audiovisual, it could be a field trip, it could be what we call different pedagogies of experiencing something, and
I
it
mean,
could be
when I learned French, the way I did it is by the teacher went through Asterix and Cleopatra, Asterix in Egypt. That's experiential learning.
right, exactly. So there's a lot of scope for role plays, for theater, for any of these wonderful things to also come in place for other subjects where making something with your hands may not be the first option. So yeah, I think we're almost how to provide experiential learning firsthand amidst this COVID menace. So yeah, I guess we'll talk about some of those implementation strategies, how things are all happening online now, and people have had to adapt very fast in the last 8 or 10 months to deal with this. Yeah, anything else you want to say, Jayanth, to close?
No, it's just, the only thing I wanted to say is that just to reiterate that I focused on science, but really it's not science. I mean, what we're teaching is how to think, and how to think applies in anywhere: language, history, geography, anything. You can teach how to think, and you just have to find the right activities for that. That's what I think is important.
Lovely. Yeah, and I think I'd like to end with a quote from one of my mentors and teachers, who was the principal of the Valley School, Dr. Satish Namdar, who passed away about 4 years back. In his last speech in our school, he said, "In this school, we don't tell you what to think; we tell you how to think." And I think that's the important part. And I hope all of us try to think about just that simple line. It's also what Jayanth just said, and it immediately rang a bell. So let's try and do that when we are working with our children in schools and so on. Jayanth, thanks a lot for being here with us today. It was an honor and privilege as always. And thank you again. Vishal, back to you.
So one thing before we continue the workshop further, just wanted to, it said that when we are thinking, it is questions which help us move, which help the thoughts move forward. And we are a large group. Also, though we are lucky that we are able to interact through this virtual platform, we also have limitations of we all not being able to talk very regularly. But if we continue to post our questions on the chat window and also respond to the questions which we are going to post, it would help us continue to interact and also stay active during the entire workshop. And we are starting with one such question. This question, by the way, is not for you to answer, but I still want you to evaluate and give your vote on what do you think, how would your students find this? And for you to respond to that, we are launching a poll which should get displayed on your screen. I'll wait for another 40 seconds. Okay, I'm pausing the poll here. We have got around 42% votes so far, and I see that people are continuing to respond, but in the interest of time, I'm ending the poll here and sharing the results. Okay, I see that some of you have started annotating. This is one thing which we have learned during the Corona time that whenever we have sessions, you go and start scribbling. So of course we can disable that. Please don't do that. As you can see, 86% people, so 199 out of the total 220 odd people who have responded, 199 people have said that your students should be able to answer this if they are guided. 20 people have said it's very easy, 9% of you. 7%, which is 14 people, have said it's very difficult. Okay, before I proceed further, let me go ahead and disable the annotation so that the scribbling can stop. It's amazing how these are the first things that we pick up. Okay. Of course, this was not one of those questions for which we have one right answer. Let me move to the next question. And we'll also try addressing the particular question which has been asked here. By the way, this has been picked up from this program for international student assessment, which focuses on 3 main literacies, which is reading literacy, mathematical literacy, and scientific literacy. And 15-year-old children, which are around 10th grade children from all over the world, they participate. India had participated only once, that was way back, I think in 2009 or 10. And the plan is that India will also be participating next year. Okay, so to answer the question, the particular question, let's break it down into, here is the first broken down question, which is seasons. And by the way, this is not an exhaustive list. It just happens to be some of. I hope I'm audible now.
Yeah.
Okay, let me end the poll now. It's amazing to see these results. So maximum votes, 74% people. So 168 out of the total 229 who have given the response have said it's because of the tilt in Earth's axis that one of the hemispheres is closer to sun, and that's where you'll see summers. 52% people, that is 117 people, have said distance between Earth and sun changes during the year, and that's because of the elliptical orbit. Regarding the second question, this time 65 people have said it was very easy, 152 people have said can answer if guided, and 13 people have said very difficult. Okay, so let us come back. Okay, so we are going to answer this question in a while, but in fact, to answer it, let's do one more quick experiment. And for that, I want you to respond to this. So imagine there was a paper which was placed at around 20-25 degrees from the vertical, and there was a torch which is shining light on it. This is the midpoint of the A4 paper. Which of these is correctly showing the kind of picture, the kind of image that you'll get on the paper? Again, there's a poll question being launched for this. And please be patient. We are going to come to the answer just in a while. I'll wait for another 15 seconds and then end the poll. Okay. So I'll share the results. 45% people, that is 98 of you, have said option C, that is gradient from dark bottom to light top. 82 have said B, but it's good to see that majority are talking about B and C. There are 24 people who have said the top part will be fully lit and bottom will be fully dark. And there are 18 people who have said option D as well, which means bottom will be fully lit. Regarding how easy you think your students will find it, again, the bell curve continues. So 158 people have said can answer if guided, and 42 have said very easy, 22 have said very difficult. And one of the ways to answer this question is to actually do the experiment. And since the setup would require dark room, it would have been a little complicated for me to show that, and hence I've pre-recorded the video, which I'll be sharing now. Okay, just give me a second since the video is not playing here.
We have placed the torch inside a cardboard tube here, and through that we will project light on the graph sheet which is placed behind. We'll place the graph sheet at different angles and see the impact. Now let's create a dark room and observe the light. Start. This is the circle we are getting with the 90-degree angle. Let me use a pen and mark it so that we can measure the area later. Now the graph sheet is tilted forward at an angle of 25 degree with respect to the vertical. Now let me draw the boundary of the light. Now the graph sheet has been tilted forward at around 40 degree. Let me again capture the area of the portion where light is getting projected. So here now I have calculated the area of the light, area occupied by the light. When the graph sheet was placed at 90 degree, we are getting around 86 centimeters square of area inside this boundary. when it was placed at 25° with respect to vertical, that is around 65° with respect to horizontal, then there's extra 43 squares which are coming out and an oval kind of shape, so that's 129 centimeters square. And when it was placed at 40° with respect to vertical and 50° with respect to horizontal, then around 172 centimeters square, so another 43 centimeters square of area is getting increased.
So what you saw just now is, as I said, the video which I had recorded some time back. What's very interesting to note is compared to the 0°, so when it was placed vertically like this, compared to that, when it was 40°, the total area was almost double. So also it was increasing in the increments of around 43 centimeters square. Okay, so what does that mean? As the paper gets tilted, is it that the torch starts giving out more light? Does the energy of the light coming out from the torch change as the paper tilts? Since that doesn't happen, it means it's the same amount of energy which is now distributed across more area when the paper gets tilted. And because of that, in per unit area, the amount of light intensity that you have is less. Here I have another model which shows, now imagine these are the rays coming from the sun. And in this case, the way it has been placed is, this is the north hemisphere, southern hemisphere, and it is tilted forward. So if the sun is this side, it is tilted towards, the north hemisphere is tilted towards sun, which these rays are making. So the third one from top and the bottom one. Look at the angle made by this ray compared to this ray. That's one. Second is, so as you can see here, it's closer to 90°, and because of that, the intensity of light in this region, the northern hemisphere, will be much higher compared to the intensity of light in the southern hemisphere, because southern hemisphere, it's getting spread. Other thing is, this black portion that you are seeing, that's where you'll have night. So consider a typical day. So this is the night and that's the day part. And again, as you can see, the length of the curve here in the northern hemisphere, which is not black, that is longer than the amount of black portion in the southern hemisphere. So because of the tilt, two things are happening. One is the length of the day is getting affected, and second is the intensity of light, the way it gets spread, that changes. And this is the main reason for winters and summers. Now let's come back to the the question and look at each of the options one by one. Pro, I'm assuming you are monitoring the chat, and
Yes,
if
yes,
there's anything, you'll bring it up.
correct. Some people were not able to poll last time. They weren't getting the option. So I don't know, maybe something to do with the
In fact,
device or
it's one of
something.
the most common misconceptions. Say it again, I couldn't hear.
No, I said there were some people last time who could not poll. So I guess they're having issues with their device. And there were others who are asking, what is the age group we are looking at to answer these questions to be able to talk about difficulty? Maybe you should elaborate on that, is what they're saying.
Yeah. I had thought I'll mention this. So you can assume these are the 7th or 8th grade students who are responding to these questions. I'm just launching the presentation and bringing up the season slide again. So now let's look at the answer to this question about torchlight on it. So in this case, the correct answer is option B. So it will be a gradient as majority of you said, but since the angle at which the light is falling in this region is different from the angle at which it's falling here, it will be more spread out here. And hence, and lighter together, that along with understanding of how the angle changes because of the tilt, relook at this question. Visible, the yellow arc is better than the blue arc. So the first option, all parts on Earth have summers, and you have in the northern hemisphere, if you have summer, then southern hemisphere has winter. Of course, if you pick areas which are just above or below the 0-degree latitude, then you won't see a difference. The distance between Earth and Sun changes during the year because of elliptical orbit. As I was just saying, this is one of the most common misconceptions, thanks to the drawing that we make. So to be technically accurate, yes, it is elliptical, but it's almost circular. So it's on the order of circle rather than ellipse. And also, if it was elliptical, then try to imagine we should have had 2 summers and 2 winters during the year. Every 6 months, we should have had a summer season, a winter, the season changing. Tilt in Earth's axis is, but very, very negligible. So the distance between the Sun and Earth is close to 150 million kilometers, and the diameter of Earth is around 13,000 kilometers. So it's almost 10,000 times. So the distance between Earth and Sun is 10,000 times the diameter of Earth. So even if Earth moves one Earth diameter closer to Sun, so in this case, the correct answer is the only option which was correct is option 4. Of course, this is not an exhaustive list. There are many other factors, including, let's say, the factor of how the atmosphere becomes thinner depending on the angle at which the rays are falling. And at least in this list, we have not even captured the length of the day that as one of the options. This was just the intent was to highlight some of the common misconceptions. Before I jump to the pedagogy, let's do a quick reflection on how did you find this short experience of the 4 questions. And for this, again, there is a question. You can choose more than one option here. Did you learn anything new, first of all? And if which of these, which could be more than one, this has helped you learn something
Again, inaudible, Vishal, can't be heard.
Yeah, I've been mute. Okay, I can unmute myself now.
Yeah.
So 53 out of the 231 who voted have said answering the questions that helped the most. 154 out of the 231 have said experience of light on tilted paper. So I'm assuming you are referring to the video, and explanation of how seasons occur. The explanation was also helpful for some of you, and the reflection process of how easy was the question. So let me come back on the reflection question right here. There was a specific reason we were asking that question. Let me move to the next slide. And this entire experience, the short experience that we had, we are going to relate it to the pedagogies that we are going to talk about, because according to us, this is a very quick demonstration of how we can implement a process which can help us develop the 21st century competencies in our students. One of the fundamental pedagogies which we believe applies here is the theory from this gentleman called Vygotsky. Some of you may have already heard about this theory. That to learn anything, we are usually in one of these three zones. The names of the zones are self-explanatory about what they stand for. The key thing here, which I would like to highlight, is that his theory says that learning happens in the challenge zone only. And according to me, it simplifies. It's a very, it makes the job of a teacher very simple, that if we ensure, as teacher, if we ensure it's rare to face so many technical issues. For some reason today, probably the server has a lot of load. Sorry about that. So coming back, I was saying this one statement simplifies the role of a teacher, because as long as we ensure that our students stay in the challenge zone, our job is done as teacher. The question is, how do you do that? How do you first of all know whether your students are in challenge zone or they are in the frustration or comfort zone? You need the right assessment tools for that. And once you have figured out how do you nudge them, support them in the most appropriate manner. And for that, we are proposing a combination of these two methods. One is experiential learning and other is assessment for learning. To have a glimpse of what we mean by experiential learning, we also had Dr. Jayanth speaking about it. Let's have a quick demonstration of some of the science-based experiential learning from Dr. Procheta. Pro, over to you.
Just give me a second. I'll turn on my phone camera so that you can see.
Sure.
Make it the spotlight. There you go. So I'll just show you a series of 2 or 3 quick experiments and then hand over to Vishal. So here I have a glass. Some of you may have seen this experiment before or at least heard of it in your textbooks, especially the science teachers. In that glass, I'm going to put this yellow powder, which we all eat every day, and is very much there in our kitchen. So this is turmeric or haldi. So I put a little bit of that. In another container, I have an interesting powder, white in color. We use it on our walls all the time. It's called whitewash. We use it in pan while having bida or pan. And its common name is lime powder or quicklime. Also happens to be the chemical compound called calcium oxide. Okay, so I've put some calcium oxide in the turmeric. Okay, and nothing much happens. You can see some white powder on top of the yellow powder, but I'm going to add water to this. So I have a dropper with me, and here I'm going to add some water. And I think you're already able to see that something's happening when the water mixes with the two. Okay, if I just put water in haldi, it would remain yellow in color. But as soon as I've put this lime powder and I give it a good mix as well, suddenly it's no longer yellow. It turns a deep orange, and it may even get more orange as more and more of this calcium oxide dissolves in the water. It's it's quite poorly soluble, so sometimes you need to add a little bit more and give it some time, but it changes its color. Okay, and this is a wonderful experiment to show that turmeric is a natural acid base indicator. So that's the first thing you discover. And then once you know that, then you can do a lot of science with this, right? So the calcium oxide becomes calcium hydroxide when dissolving with water, which is a base. And so whenever turmeric is exposed to a base, it changes color to red. We have a name for this color. It's called vermilion. In Indian languages, we have lots of names for it: sindur, shidur, kumkum, kumkuma, etc. So that's exactly what this is: lime powder mixed with turmeric. Okay, lime powder has calcium oxide, also called quicklime. Now, lots of books will just end the experiment here, but you can do a lot of extensions with this. In this container, I have another kitchen item. This time it's an acid. Okay, it happens to be citric acid that I have with me, and I'm going to put a few drops of that into this red. Okay, and see what happens then. Right? Change it back to yellow. So I've just done a quick neutralization experiment right there, where I've changed the pH, so to speak, of that solution back to neutral and then perhaps even acidic, and the turmeric again becomes yellow. So the turmeric can be red and we call that kumkum or vermilion, or it can be yellow and we call that turmeric. And you can use these two as your acid base indicators. You can make litmus paper with it and test a series of substances at home for their acidity or their whether they're acidic or basic. If neither change color, if the kumkum also doesn't change color and the haldi also doesn't, then you know that that substance is neutral. Okay, so that's how interesting you can make a series of experiments just using turmeric in your home. Okay, we've had kids take 50, 60 items from their house and make a list of it and show that, oh, this is how, I found these to be acidic, these to be basic. With food items, there are lots of surprises that can happen. Okay, so that's a nice chemistry experiment. Lots of explorations possible. You can also make it do some titrations, and what we just did, a neutralization experiment, right, to convert it from basic to neutral, and then you can do some measurements too to make it even more exploratory. Now I'll show you another experiment. I have with me here a bottle which I've cut at the bottom. Okay, on top, on the bottle cap, I've put 2 safety pins, and in the safety pin I've connected like a toothpick here, and on that I've put a cardboard turbine. Okay, what does that do? I have a mug of water with me here, and when I push this bottle down, the turbine starts to rotate. It's marvelous. There's a hole in the bottle cap where I've put a straw so that the air comes out, and that hits the turbine and rotates. What is this a representation of? You can see the bottle going in the water. So the water replaces the air in the bottle, and the air is pushed out through this hole and rotates the turbine. So this is a simple model of a wave turbine model. So that's how that would work, where if you have a column that's kept under the sea, as the waves come in and push the column of air up, it can rotate a turbine and you can generate electricity that way. And this is a wave turbine model. You can see that only when I push down, the turbine rotates. When I pull up, the turbine doesn't rotate. Another interesting aspect of this, the axis is horizontal, but the air is coming from below and directly hitting the blades and rotating a horizontal axis turbine that's kept. What more can I do with turbines when it comes to, say, wind blowing on a turbine? Those work in a slightly different way. So I'm going to turn on my ceiling fan, and here with me I have another turbine. Okay, so what can I do with this? This is to distinguish between the horizontal one. Here I have a vertical axis one and fan blowing air from this way, and here the plane of rotation is perpendicular to the rotation to the direction of the wind coming in. Quite different, or slightly different from the wave turbine model that I have. So the turbines are slightly different. It's just to show you the kind of different things you can do with different materials, very simple materials, and you can make your own wave turbine model, or your, in this case, a wind turbine model as well, right? So this can be taught in various classes, and talking about not only energy conversion, but also things like renewable and that on the environmental aspect of things. I'll also end my side of this by doing a quick experiment where I'll make the thing in front of you. Okay, and this is a very interesting activity. With me, I have a piece of filter paper. It's actually half a piece of filter paper. The other half I've already used to do exactly what I'm going to do with this. Okay, I have a strip of magnesium. This could be any metal, but in this case, it's magnesium, and this is how it comes, these magnesium ribbons. I've taken a strip of that, and I'm going to fold this filter paper over this magnesium ribbon, okay, just to encase it in this filter paper. And on top, I have a little bit of the magnesium left. I have another metal with me, a metal ribbon. This is copper, okay, as you can tell by the color. And I'm now going to wrap this whole thing in copper. So the size is perfect, whereby I'm able to just wrap this whole thing in the copper ribbon. And the idea here is that the copper should wrap the whole thing, except it should not touch the magnesium. So I have magnesium jutting out on top, then a little bit of the paper so that the copper doesn't touch the magnesium. And then I have the copper, and I have something in my hand that is ready. Okay, I have an identical same thing in my hand. Okay, so I have two of these. What I'm going to do with this is I'm going to connect the copper of this cell. I'm already calling it a cell, but I'm going to connect the copper of this to the magnesium of the other. So they're two identical, what you would call a cell, and I connect the copper of one to the magnesium of the other, and I kind of bend them towards like this, because what am I going to do at the top? I have these two free ends now, one copper, one magnesium, and with me I have an LED, a light emitting diode, which is nothing but a electronic piece of equipment which gives out light when electricity goes through it, but it allows current to pass only in one direction. Okay, that's why we call it a diode, which is nothing like, it's like an electric valve. It allows electricity in one direction. So you have to be mindful. The longer leg is the positive leg. That's the one that connects to the copper side of the free side of what's now become a 2-cell battery. Okay, and the shorter leg, which is the negative, that connects to the magnesium. And what theory tells us is that once I connect this cell to this, it should start glowing, but we don't see it glowing. Okay, so it's something missing right here. Okay, so let's see. With me, I have a glass of water, and in that, I'm going to add the same little bit of citric acid that I used earlier, right? So just a few drops of it. This makes water something called an electrolyte, which means it suddenly should be starting to able to conduct electricity. Okay, and now if I dip this, what I'm claiming to be a battery, inside this, what happens? The LED starts to glow immediately, right? And it will stay glowing as long as there are no short circuits and it's connected, as long as and I can keep dipping it and keep it dipped also, but I don't need to. Once it's dipped, I can take it out, and as long as the paper is wet, the filter paper between the two, the LED glows. So this is a battery that I've made with two metals, a separator and an electrolyte, and a red LED to show you how a battery can be made. A lot of exploration possible with this. I won't go into the details because we are of course quite short on time, but this was just to give you an example of how simple it is to make something that can be quite wondrous and have a wow factor. I always really enjoy making this. Okay, over to you, Vishal.
Thanks, bro. So the intent behind showing these experiments was more to give an idea of how experiential learning doesn't necessarily need extraordinary resources. Of course, it depends on the learning objectives, but even some of the most complex learning objectives can be met using some of the very simple materials which we have around us. PPT again to take this forward. So we had selected this as a small subset of what we are calling as tactile activities, which are linked to some of these topics in NCERT syllabus. Something which I skipped demonstrating is microscope. If we get a chance, I'll show that very quickly. A simple microscope mounted on an ice cream stick. The as far as the pedagogy, that is the experiential learning, experience alone is not sufficient. For that matter, if we consider the example of seasons, we all have been experiencing seasons every year. Though that the climate changes, monsoon, etc., are getting disturbed significantly, we still have summers and winters happening. And if experience alone was sufficient, then we all should have got that answer right. Usually for any experience, once after you go an experience, you need to reflect back on the experience. If I stumble upon an obstacle, it's important subconsciously, but whenever we reflect back on the experience, that's when the actual learning happens. And when we want to drive towards a very specific learning, then the observations also need to be guided. What you see in the picture next to these stages of Kolb's cycle are some of the pictures of some examples of the resources. So when it comes to science experiment, typically our observation worksheets, we, for example, ask children to predict before they actually observe, which makes them prepared for the results that they get. After the reflection is done, it's equally important that the conceptualization process that is facilitated. This is the stage when there's an interaction with the teacher, and this is also the stage when the effective nudging should happen. Quite often, the children who are more hungry, who, let's say, have already got what we are explaining to the rest of the class, they end up creating more challenges for themselves because they are not happy in the sitting in the comfort zone. And the next level helps. So for example, with the same seasons question, if we throw a thought experiment at this stage, that fine, if there is no tilt, then there are no seasons on Earth. How does it happen on Moon or Mercury? And of course, that means I need to find out if Moon or Mercury, they have a tilt. What about their orbit? Is it that elliptical orbit can never cause seasons? That may not be true about Mercury. So that's the conceptualization stage, which is where there is a guided distillation of the experience and reflection. And after that, this the last stage is when the learning actually gets multiplied, because now I've experienced also distilled out my learning out of it and stored it in my memory, but then I'm open about changing it. And more I'm open, more I would learn. And that's where I would actively go and try exploring many other things. So that's the fourth stage. As per David Code, the fourth cycle, it can start from for a true experience. The four stages. What you are seeing in the picture are just some pictures of some of the resources which we developed for science experience. Similar resources may be required for experiential learning and other subjects. Again, as I said, there are some terms which, especially given that we are talking with experienced teachers, you may be already familiar with. So here is a quick Bloom's taxonomy pyramid. And as you may be aware, starting from apply, analyze, starting from the application thinking skills is what is often referred to as skills. And quite often some of these other thinking skills like observation, prediction, estimation, collaboration, these are also categorized under the higher order thinking skills. Put on paper or they are necessary. And this is more of a voting kind of question, which I'm again launching through the poll. And while responding, you may think, you may consider that, yeah, maybe your objective is to make them remember something or make them understand something. In that case, do you still need to worry about higher order thinking skills? I'll wait for another 10 seconds and then end the poll. I simply love this participation. Thank you everyone for responding to these polls. It helps us talk even though we are in such a large group. And that's one of the blessing in disguise of this virtual platform, that anonymously we can vote. We don't need to worry about, we feel safe in giving our vote, right? So 72, so 34% people have said it's good to have, 67% have said it's necessary. And I'll share my perspective here. The reason I had brought this up is, in my opinion, if you go by the theory which is stated by Bloom's taxonomy, as you go higher up, the thinking skill subsumes the other thinking skills below in the pyramid. So if I make the students exercise an application thinking skill, then I'm automatically making them exercise the comprehend and knowledge thinking skills. The beauty of HOTS is to make the mind active, and for actual learning to get constructed in the learner's mind. If you are really interested in having the learner construct the learning, then the mind needs to be active. Whereas when I'm passively listening, when I'm just absorbing whatever is being thrown at me, that's when my mind is passive. So even if your learning objective is to make them remember or just know something, just understand something, even then HOTS is the way to go. And according to us, the higher order thinking skills, the emphasis on this has to flow through the entire learning process, starting from designing your learning objectives to the assessment plan to lesson plan. And these are some of the, this is some mapping of the verbs which one can think of. Of course, this is more of a guideline. You may have a show learning objective, but it can make the child exercise, evaluate thinking skills. But this is more of a guideline. It makes us aware of keeping thinking skills in mind while designing the learning objective. So extending the same theme, here are some questions which I have copied from one of the worksheets. If you look at the first question, the fill in the blanks, where I would answer it correctly if I know where know what is an equator on the globe, or same for the second or third question. So the results of testing are either I know about it or I don't know about it. There's nothing more that a teacher can conclude about it. On the other hand, when the focus shifts on testing knowledge as well as competency, then what happens is, even if I know, if I have to think while answering the assessment question, then I'm learning even while getting assessed. And that's what is meant by assessment for learning. And that's effectively our proposal, that if the objective is to meet this subset, to achieve this subset of NEP, which is to develop the 21st century competencies in our students, then a combination of assessment for learning and experiential learning based on the zone of proximal development is one of the methods of developing it. And when it comes to actually implementing it, the 5E model, it gives us a framework. Just to run you through the 5E model, the first stage, which is the engaged stage, because when a student is engaged, then that's like an open box ready to receive and whatever we throw in that. So in our case, the first question which we had put across, that could have worked like an engagement tool for some of you. But it could be a game that we start with. It could be an energizer, a physical energizer, or a quick demonstration. Explore is when we start looking at that topic from various angles. And this is when the communication, because when I communicate, when I explain back, which applies to teachers as well, quite often people say that you become a teacher and you'll learn the concepts better yourself. Because when I have to explain it, I need to understand it better. So that's one of the crucial stages. And of course, then the right nudge required to extend it to other areas. Like in our case, the thought experiment of Mercury and Moon was a wonderful example of how do you extend it to other situations. And at the end, I want to know where I stand as a student. And that's where evaluate stage is a crucial one. So let me just make a clarification that what we have done is a very, very brief overview. It's not possible to go in depth into each of these in a 90 minutes workshop. The idea was to give you an overview, and if you like it, let's partner together and we can develop this further and share the learning with each other as well as with other schools. So some of the options are here, which are also part of the feedback form, which we would like you to fill. Those of you who fill the feedback form will be sent an e-certificate from Bangalore Sahodaya. And as part of the feedback form, there is an optional page, which is about if you would like to partner with us, then which of these options you would be interested in. That helps us know which ones we can contact you for. Some of the options are this free science literacy program, which we are developing in partnership with the CBSE board. We plan to do a pilot with the 7th grade students of few selected schools during the February month. If you are interested in participating in this, please indicate that in the feedback form. And of course, we have also been running experiential learning sessions for children in the science space, and we have the resources related to that. And we will be starting a 10-module teacher training program, which would also have 5 modules from the National Education Policy 2020. If you are interested in that, let us know so that we can contact you when the program starts from April onwards. This is the QR code which you can scan to fill the feedback form. And I suppose my colleague Raghu would have pasted the link to the feedback form in the chat window as well. Raghu, can you confirm if you have
Yeah.
the link
Raghu
on
has
the chat
shared.
window? Yeah.
Raghu has shared.
Nice. Okay. Sure. There is a request to show the learning objective slide. I suppose, Sumaya, you are looking for the verbs slide, the verbs associated to Bloom's taxonomy. I'll show that again. Just one. Okay, Tia ma'am has also said the same thing. I'll show it. The good news is the document which CBSE and NCERT they have prepared on learning objectives and learning outcomes, that already takes this into account for all the grades. So if you are a CBSE school, you can also blindly follow that, as long as your lesson plan and assessment plan ensures that the learning objectives and learning outcomes are kept in mind. It will automatically ensure that certain focus goes on competencies as well, on thinking and skills part other than the knowledge part. Okay.
Gone silent. Yeah.
Manila ma'am.
No. You're fine, Vishal. Yeah.
Yeah. Am I audible? True?
Yeah.
Yeah. I was just requesting Manila ma'am to. Yeah. Manila ma'am, is there anything that you would like to add before we close the session today? Yeah, I think you're speaking on mute, ma'am. Can you hear me, ma'am? You're speaking on mute, Manila ma'am.
Yeah, she's unable to unmute. Ma'am, I've made you co-host. You should be able to unmute now.
Okay.
I think you must have dropped off.
Yeah. I dropped off. So I joined back again on my phone. Yeah. Thank you so much for making the learning so very interesting for all the participants. And I'm sure, many principals and teachers would love to get in touch with you for making this learning and experiential learning for the children. And since, you are doing it for 7th standard children, some of the activities, I would be sharing your contact details with the principals in case they reach out to me, so that many schools you can enroll for this learning for standard 7. And of course, we had some technical issues in between, the voice was dropping and little,
okay.
Yeah. So, but otherwise things went on very well. So participants can fill up the feedback form. Only based on your feedback form, you'll be receiving the e-certificate. So please make sure you write your mail ID correctly without error, else you will not receive the certificate. So thank you so much, ThinkTac, and all of you for organizing this program for Bangalore Sahodaya. We really enjoyed interacting, and I think though the large number, everybody made it a point to participate and raise their concern, question, and they took part in your answering the question. It was something interesting. So thank you so much. Special thanks to Mr. Prasad. I don't know if he's there today, who contacted me and we were in touch, to organize this program. Special thanks to him. So thank you so much once again.
Thank you. Thank you.
Yes.
Our special thanks to Bangalore Sahodaya for giving us this opportunity, ma'am, and participative. That just makes us make the interaction smoother and free flowing.
Yeah.
Okay.
Yeah.
Thank you, ma'am.
Yeah.
Thank you, everyone who participated.
But please
Hope to
ensure that
work
they
with
fill
all
up
of
the
you.
feedback form. Yeah. After feedback form, you can end the meeting. They have to fill up the feedback form.
Thank you. Should I end the meeting?
Yeah, once they filled up the feedback
Okay,
form,
after they filled it up, is it?
I think you can wait for another 2-3 minutes for to fill up the feedback form.
Okay.
Yeah.
There's a request by someone for demonstration of a biology activity. Let me see if I can show this while they're filling the feedback form. So the microscope which I was talking about, that's as simple as this. So on an ice cream stick, there is a glass bead which is installed in the ice cream stick. And when you place it on the slide and point it to a light source, then you can see the slides. Let me see if I can give you that experience by, so I have placed it behind the phone, mobile phone, and I'll project this so that you can see it. So you have, can you put this on the spotlight?
Yeah, I've put it in.
Maybe hard to find in the.
Very beautifully visible. Yeah.
So I guess as you can make out, some of you, these are the onion peel cells which we are observing through a microscope. How it has been done is as I just explained. So behind the mobile phone, the microscope has been installed, and the microscope is essentially a glass bead fixed inside an ice cream stick. And if you want to see that more clearly, I'll show it once again. So as you can see, it's just an ice cream stick. There are two glass beads here. That's a smaller glass bead. That's a slightly bigger diameter glass bead. If you look at any lens, as the size decreases, the focal length decreases, but the magnification increases. Because the focal length is so low, you need to place it on the object. On the microscope, you have the light coming from the bottom through the mirror. In this case, we need to point it to a light source. And because it is so portable, I'm able to just install it through one rubber band behind the mobile camera. And that's how simple it is, which is one of the points we want to make, that experiential learning is so effective, but it doesn't necessarily imply lots and lots of resources.
Raghu, some people are asking for the link again. Can you post it? Oh, okay. Thank you, sir. Oh, thanks, Jeevan.
Nidhi ma'am, you want me to repeat the microscope making? Yeah, as I said, the crucial material is the glass bead. So we provide these glass bead and children make a hole using a scissor and then using a tape. So it's just a simple black tape which is fixed here. Here we have a small rubber piece so that the glass bead stays in its place. And that makes the microscope ready. It's as simple as this. So in a regular microscope which we use in labs, we have compound microscope because the magnification happens through two lenses. In this case, it's a single lens, but the single lens itself gives the small bead, the 2.5 millimeter diameter bead, that alone gives around 110, 120x magnification. And the 4.5 millimeter diameter bead, that gives close to 20x magnification. So we can have children look at the leaf venation till the cell structures, the entire range, depending on how much magnification we are looking for. Because otherwise with a conventional microscope, it's difficult for us to make them study the leaf venation because it zooms in too much. So that's one benefit of these portable microscopes. I hope I clarified it, Nidhi ma'am, what you asked for.
You can wind up now, no?
Okay.
Okay.
Okay, ma'am. Thank you.
Yeah, thanks.
Okay. Thanks very much. So I'm ending the call.
Yeah.
Okay.